Right, okay, then this is the problem that we've been presented with. Let's talk about air resistance on Excel. So I want you to model it, and if you follow these steps, what should happen is you should be able to build up a spreadsheet that looks not too dissimilar to this. I've put a little diagram here. If you're interested in that, then I put it by insert and inserted object and equation editor, and then I inserted as well some simple clip art symbols, etc. Now, what I do is I place G, delta T, and mass up here, and those are the values that I'd like to change. And what I'm going to demonstrate first of all is how we use these values and use them to change the grid straight away without having to go through each individual cell. So first of all, time equals 0 is 0. Okay, next one down. What we need to do is we need to add the previous time to this little interval, delta t. As we press return, we get 0.2. And you'd imagine at this point, all that I'd have to do is drag this down, and I'd get 0.4, 0.6, etc. But there's problems occurring. This cell is correct. I'm looking at the previous, add it to delta t. However, when I move down to the following cell, and I click in it, you notice that though the blue cells come down, which is correct, so has the green cell, and I want to hold the green cell around the delta t. So what I do is, I go back to my original cell, and I put a $sign on either side of the letter, thereby holding this one in place. Let me demonstrate. If I now drag that down, I now, let's say much further down, I look at the cells, I'm using the one above, but that cell has been locked in place. Excellent. Now, if I change the delta t to 1, all the numbers change. 0.2, all the numbers change. Oops, wait a minute. This one, 0.2, these numbers will change. Excellent. Now, for the velocity. The velocity, of course, what we're looking for is we're looking for the previous cell, like we did before, and then add it to my acceleration that I was at by the time period. Obviously, each one of these columns is going to affect the previous one, so let's move across and work out the air resistance. The air resistance is kV squared. So 0.25 is my K value, multiply it by 2 gives me the air resistance. My acceleration in turn is going to be, this is in effect 600 because it's the mass times 10 on Earth, minus the air resistance and dividing it totally by the mass again. And that gives me my change in acceleration. And then the distance travelled is going to be the velocity which it's travelling at, multiplied by the time period. And what I should do there is just add the previous distance to it. Now if I grab all of those and drag them down, suddenly we start getting values which are as we'd expect. Drag it down even further. And the last step in the way would be to highlight these two, insert a chart, and if we look at the scatter, it's starting, I'd say, to look as we want it. Of course, you're going to take this to something like 50, so you really drag that right down. But I'll leave you to try the rest of it. Okay? Happy excelling.